setup at the counter. I go to the counter setting. We could see here on the left side the input channel. So we have free programmable thresholds when you use other sensors. This is related to rotation, so we get 1800 pulses per revolution, and we have the A input, and we use the real hardware reset with the set input, so we get here the absolute angle from 0 to 360 degree. So this is the basic counter setting. The channel what we get out is here the angle from 0 to 360 and the speed. The speed is what we will go and use for the rotational vibration measurement. Let's now go to the measurement. I will now start storing, and I will do a run up. And we could already see now that here around 2200 RPM, this the RPM. On the upper the green one is the speed. On the bottom we could see the rotational vibration. We could see at a certain RPM, it was 2000 RPM, we get a kind of board line, looks like noise, but we will in a minute do further investigation on this, and and like you can imagine, we would see here then the rotational vibration. So let's do a quicker shot. Goes down, and I will stay here at 700 RPM. I will now stop and zoom out this area, and when we investigate this area where it looks noisy, and we zoom into this area, you can see both recorders are linked, so they zoom in the same time axis. We could see that here in this area we have oscillation, so the RPM is deviating for almost 250 RPM. So when I zoom out, we could get this here on the bottom. It is the rotational vibration, so it is the filtered RPM deviation. So we remove the DC component, so this the static RPM in between, and only show the rotational vibration, which is the RPM deviation. When I have a look here in this area, we get the same picture. Also here in this area we have the oscillation available. Here, to have a further look, I will go to the next page. Here I prepared, let's zoom out a little bit and let's investigate this area, and we could see here FFD. So when I go into this area, we could see a peak at 32 Hertz. This equals to 1800 RPM, and this is also indicated in this waterfall diagram, which is written over time, that we have here this significant peak. So when I go now further into this area, and we have here the complete FFD in this diagram, we could see the hotspot at this area, which is related to this area at 10 seconds, and we could see the second hotspot at goes down. So we can zoom into this area and check this in more detail. So at this measurement, we could clearly see that we have some problem with rotational vibration at the area of 1800 to 2000 RPM. Here the drive shaft starts to oscillate, and this will cause in a noise vibration. This was a basic introduction of the rotational vibration measurement.